There's a moment, standing among the stones of Great Pyramid of Giza, when the scale stops impressing you and the details take over. Not the towering height, not the desert horizon, but the marks left behind. Subtle, deliberate, almost defiant. Marks that shouldn't exist if our assumptions about ancient technology were true. Because when you look closely at the granite blocks scattered across Giza Plateau, you begin to see something unsettling. Perfectly formed cylindrical holes. Smooth internal walls. Precision that feels modern, except it isn't. These cuts were made nearly 5,000 years ago, in a world without steel, without engines, without electricity, and that's where this story stops being about history and starts becoming a lesson in survival. Because what the ancient Egyptians understood wasn't just how to shape stone. They understood how to work with limits, how to build systems that didn't depend on excess energy, rare materials, or fragile complexity. They built methods that could endure disruption, scarcity, and time itself. And that raises a question worth taking seriously. In a world where we rely on speed, power, and constant consumption, what happens when those things disappear? What remains when the systems we depend on fail? Stay with this, because what we're about to uncover isn't just a mystery carved into granite. It's a blueprint, one that could change how you think about resilience, engineering, and survival in the real world. The story begins with what seems like a contradiction. For generations, the standard explanation has been simple. Ancient Egyptian craftsmen used copper tools to drill into stone. But when you examine that claim with even basic material knowledge, it starts to fall apart. Copper is soft, granite is not. On the Mohs scale, granite is more than twice as hard. If you pressed a copper tube against it, you wouldn't expect cutting. You'd expect failure. But failure didn't happen. Instead, the Egyptians produced holes so clean and consistent that modern engineers have struggled to replicate them under controlled conditions. And the key to understanding this lies in something deceptively ordinary: quartz sand. The copper itself was never meant to cut. It acted as a holder, a structure that carried the real cutting force. When mixed with water, fine quartz sand formed an abrasive slurry. As the copper tube rotated, those microscopic grains embedded into its surface. Suddenly, the tool transformed, became a constantly renewing cutting edge, powered not by hardness, but by process. Each grain did a tiny amount of work, individually insignificant, but together relentless. Over time, that quiet abrasion carved through granite with a level of control that avoided cracking, avoided overheating, and even polished the surface as it progressed. This is where the survival lesson becomes clear. The Egyptians didn't rely on overwhelming force. They relied on understanding. They built systems that used what was available, what was renewable, and what wouldn't destroy the material they were working with. In modern terms, they optimized for efficiency and longevity, not speed. And that difference matters more than most people realize. Because when resources are limited, and in any real survival scenario, they always are. The ability to achieve results without burning through tools, energy, or materials becomes the difference between success and collapse. But the deeper mystery doesn't end there. In the late 19th century, William Flinders Petrie uncovered something that forced even experts to pause. A cylindrical core extracted from a drill hole at Giza revealed a continuous spiral groove along its length, not random scratches. A consistent, measured pattern. When Petrie analyzed it, he calculated the rate at which the drill advanced with each rotation. The result was staggering. The feed rate appeared to exceed what modern drills could achieve under similar conditions. Even today, that detail remains debated. Some researchers like Christopher Dunn have suggested the possibility of advanced mechanical systems or vibrations we don't fully understand. Others, such as Denny Stocks, argue that human-powered methods, combined with pressure, rhythm, and slight tool instability, could account for the results. But regardless of which explanation you lean toward, the takeaway remains the same. The effectiveness of the system did not come from a single tool. It came from how every part of the process worked together. Material, motion, pressure, and time all aligned toward a single outcome. That principle translates directly into survival, because when systems fail, tools break, or conditions change, what matters most is not what you have. It's how well you understand how to use it. The Egyptians weren't dependent on a specific device. They were masters of a method that made their knowledge far more resilient than any single piece of technology. Nowhere is that mastery more visible than in objects most people overlook. Long before the pyramids reached their peak, Egyptian craftsmen were producing stone vessels from materials like diorite and basalt, stones so hard that even modern machining them requires specialized equipment. These weren't rough containers. They were precise, symmetrical forms with walls so thin they pushed the limits of what seems physically possible. Some of these vessels feature narrow necks that make internal carving extraordinarily difficult. And yet the interiors are smooth, balanced, and geometrically consistent. Modern analysis has only deepened the mystery. Researchers like Maximilian H. Vomarch Zamel have used high-resolution scanning to measure these artifacts. The results show levels of symmetry and centering accuracy that approach the limits of modern measurement tools. That kind of precision doesn't come from guesswork. It comes from repeatable systems. It's from training, discipline, and an understanding of feedback that allows craftsmen to correct errors before they become visible. And that brings us to a point often ignored in survival discussions. Skill is infrastructure, not tools, not machines. Skill, because tools can be lost, systems can collapse. But a trained individual, or better yet, a trained group, can rebuild from almost nothing. The Egyptians didn't just pass down knowledge. They embedded it into their culture, ensuring that each generation could replicate and refine what came before. Which leads directly into the final piece of the puzzle: organization. For years, popular narratives painted pyramid construction as the product of forced labor, but excavations at worker settlements near Giza tell a different story. Evidence shows structured communities with access to food, medical care, and coordinated labor systems. These were not disposable workers. They were participants in a national effort. During the annual flooding of the Nile, when agriculture paused, the state redirected labor into construction. This wasn't just efficient, it was adaptive. It turned a seasonal limitation into an opportunity for progress. And that's a survival strategy in its purest form. Instead of resisting environmental constraints, the Egyptians integrated them into their system. They aligned human activity with natural cycles, reducing waste and maximizing output without overextending resources. It's a reminder that resilience is rarely about fighting harder. It's about adapting smarter. So what do we take from all of this? First, the idea that process outweighs power. When you understand your materials and your environment, you don't need brute force. You need consistency, patience, and a system that works with reality instead of against it. Second, the recognition that coordination multiplies capability. A single individual has limits. A well-organized group, even with simple tools, can achieve outcomes that appear impossible. And third, the understanding that durability matters more than speed. The Egyptians built for permanence. Their methods minimized stress, reduced damage, and produced results that have lasted for millennia. That mindset stands in sharp contrast to modern systems built for rapid output and short-term gain. And that contrast should make you think. Because the real question isn't how the Egyptians drilled granite or carved stone with such precision. The real question is whether we, with all our technology, are building anything that will endure the way their work has. History has a way of preserving what matters and erasing what doesn't. So now it comes down to you. Do these artifacts point to lost technologies, or do they reveal a level of human discipline and understanding we've underestimated? Drop your perspective in the comments. This is a conversation worth having. And if you value deep real-world lessons drawn from history, not surface-level myths, subscribe to Intelligent Survival, share this with someone who still believes the past has something to teach us, and stay connected. Because the next breakthrough in survival thinking might not come from the future. It might come from something we've already forgotten.